Hey everyone, and welcome back to the channel. Have you ever been eagerly refreshing a web page, perhaps waiting for a new product drop or concert tickets, only to suddenly hit an error message like 429 too many requests? That, my friends, is a rate limiter in action. And today we're diving deep into why these invisible guardians are not just a convenience, but an absolutely critical component for nearly every online service you use daily. So, what exactly is a rate limiter? Imagine a bouncer at a popular club. Their job isn't to stop people from entering, but to control the flow, ensuring the club doesn't get dangerously overcrowded. A rate limiter does precisely the same thing for your web servers or APIs. It controls how many requests a user, an IP address, or an application can make within a specified time frame. It's a fundamental concept in system design that ensures stability, security, and fairness. Now let's get into the why. Why are rate limiters so incredibly important? There are several compelling reasons. First, and perhaps most crucially, rate limiters prevent abuse and distributed denial of service or DDoS attacks. Without them, a malicious actor could flood your server with millions of requests per second. This overwhelming traffic consumes all your server's resources, its CPU, memory, and network bandwidth, making your service completely unavailable for legitimate users. Rate limiters act as a robust first line of defense, detecting and blocking or throttling suspicious high-volume activity before it can bring your entire system crashing down. They protect your infrastructure from being weaponized against itself. Secondly, rate limiters are vital for maintaining service quality and stability. Even without malicious intent, a sudden, legitimate surge in traffic, think of a viral marketing campaign, a popular product launch, or a major news event, can overwhelm your servers. If everyone tries to access the same resource at the exact same second, your system can become slow, unresponsive, or even crash. A rate limiter ensures that your system can handle the load gracefully, serving requests at a sustainable pace rather than buckling under unforeseen pressure. It keeps your service running smoothly and reliably for everyone. Third, they are crucial for cost control. Running servers and processing requests costs money, especially in cloud environments where you often pay for compute time, bandwidth, and API calls. Uncontrolled requests, whether malicious or accidental, can quickly rack up massive operational bills. A single runaway script or a poorly designed client application could inadvertently generate millions of requests, leading to unexpected and exorbitant expenses. Rate limiters help you manage these operational costs by preventing excessive resource consumption from any single source, keeping your infrastructure expenses predictable and within budget. Fourth, rate limiters ensure fair usage and equitable resource allocation. Think of shared resources. If one user or application consumes all the available capacity, others suffer from degraded performance or complete unavailability. Rate limiters prevent a single noisy neighbor from monopolizing the system. By distributing access fairly, they guarantee a reasonable quality of service for all users, which is particularly vital for public APIs, where different clients rely on the same infrastructure. Fifth, they significantly enhance security against brute force attacks. Beyond DDoS, rate limiters are indispensable for preventing attacks like credential stuffing or brute forcing passwords. Imagine an attacker trying to guess your password hundreds or thousands of times per second. By limiting the number of login attempts from a single IP address or user account within a specific time frame, rate limiters make these automated attacks impractical and time-consuming, dramatically improving your application's security posture. And finally, for businesses, rate limiters are a powerful tool for API monetization and tiering. Companies that offer APIs often use rate limits to differentiate between service levels. For instance, a free tier might have a low request limit, while premium paying customers receive higher limits and guaranteed performance. This allows businesses to create flexible pricing models, manage the load from free users, and ensure that their paying customers receive the dedicated resources and performance they're paying for. In essence, rate limiters work by tracking the number of requests made by a specific entity over a set period. Common algorithms like Token Bucket or Leaky Bucket allow a certain number of requests or tokens to be processed per interval. If you run out of tokens, your subsequent requests are either delayed or rejected with that familiar 429 error. This intelligent, automated management is what keeps modern web services robust and resilient. So from preventing devastating cyber attacks and managing operational costs to ensure fair access and stable performance, rate limiters are not just a nice-to-have feature, they are a fundamental building block of resilient,